In this video, we're going to determine whether a three-variable system has one solution, no solution, or infinitely many solutions. So to start off the bat, I'm going to remind you that if it's one solution, you are going to actually find an answer of an ordered triple with x, y, z. So if you're getting an answer, that means that that particular system has one solution. And what we're going to do is we're going to look at situations where there's no solution or infinitely many solutions, so we know how to identify when these two situations are taking place. So in order to determine how many solutions a system has, we actually have to jump in and start solving it. So you can choose to eliminate whichever variable you would like in this situation. I'm going to choose to eliminate z just to mix it up a little bit because I notice that there's a single z here and I can easily manipulate that equation so I can use elimination with the other two. So I've made the choice that I'm going to eliminate z. So in order to do this, I'm going to pair up equation 1 with equation 2 and with equation 3. So let's start off by pairing up equation 1 and equation 2. So here we have x plus y plus z is equal to 2. And then we have 5x plus 5y plus 5z is equal to 3. So what we're going to do is we're going to manipulate that first equation by multiplying it through by a negative 5 in order to make that coefficient of x negative 5. So here we have negative 5x minus 5y minus 5z is equal to negative 10. So now what we're going to do is we're going to use elimination. We're going to add straight down, and we're then going to see what happens. So what I'm noticing here when I add straight down is that the x's eliminate, the y's eliminate, the z's eliminate, and I'm left with 0. And I have 0 equals negative 7. Now if you're looking at that confused because you're stating, well, all the variables eliminated and I'm left with a statement that is very, very clearly false because 0 does not equals negative 7, good. If you're solving along and you're using elimination and you end up with a statement that is false, this is actually a situation that has no solution. So there is no combination of x, y, and z that makes all three of these equations true. So here, let's try another problem. So again, I can choose whichever variable I'd like to eliminate. I'm going to choose this time to eliminate the z's again because I notice there's a lot of easy combining with, if I combined equation 2 with equations 1 and 3, all I have to do is add them together, which is pretty sweet. So I'm going to take equation, remember I'm taking equation 2 for both. I'm going to do equations 1 and 2. So I have x minus y plus z is equal to negative 3. And then I have x minus y minus z is equal to negative 3. So if we add straight down, we have 2x minus 2y. The z's cancel out, and that equals negative 6. So I have one equation with two variables here from combining equations 1 and 3. So moving along, I'm going to combine equations 2 and 3, because again, all I have to do is add them to eliminate z. So I have x minus y minus z is equal to a negative 3. And then I have 5x minus 5y plus z is equal to negative 15. So again, I add straight down to eliminate, so I end up with 6x minus 6y. The z's cancel, and I have equals a negative 18. So I now have two equations with two variables, so I can combine those together to be 2x minus 2y is equal to negative 6. And I also have 6x minus 6y is equal to a negative 18. So what I'm going to do is I'm going to multiply through that top equation by a negative 3 to get the coefficients for x to match. So this one becomes negative 6x plus 6y is equal to 18. And if I add straight down, I end up with x's canceling and y's canceling. So I have 0 equals 0. So I tried solving this, and I ended up with this statement of 0 equals 0. If you end up with this statement, and you notice that this statement is true, good. That's what you should be noticing. So if we try to solve this using elimination and we end up with a situation with no variables that is true, this is a situation that's telling us that we have infinitely many solutions. So what that means is that when our three planes cross, they're crossing in a way that is a line of points. It's not just a single point in the 3D world. And as a result, we have to represent our answer as infinitely many solutions.